afternoon, everyone. Our topic for today is all about the 16th century of mathematics. The 16th century saw several developments, some of which pointed to definitive resolutions of themes from earlier centuries, and others of which reflected the movement of the subject into entirely new directions. And the most celebrated breakthrough was the discovery of formulas for solving the third and particularly of polynomial equations in one answer. So you can encounter here the different discovery during this period, and we will discuss about the solutions for cubic equation, quartic equation, together with symbolic notation and decimal expansions, including their contributors. So the first discovery is the cubic formula. It is in the form of ax cubed plus bx squared plus cx plus d equals 0, in which a is a non-zero. Solution of this equation are called roots of a cubic function. It has at least one real root if all the coefficients a, b, c, and d of the equation are real numbers. Cubic equations have roots that are irrational and even not real complex if the coefficients are rational. There are three contributors for discovery of solution for the cubic formula. So the first contributor is Scipione del Ferro. He is an Italian mathematician who found a method for solving a class of cubic equations in the term of x cubed plus mx equals to n. All cubic equations can be reduced in the form if n and m are negative. But during that time, Delfer didn't know about negative numbers, so he kept this equation as a secret. But before his death, he told his student named Antonio Fior about his secret. Second contributor is Niccolo Fontana Tartaglia. He is an Italian mathematician who is proficient with binomial expansions. He was a prodigious calculator and master of solid geometry, and also know of Pascal's triangle 100 years before Pascal. The last contributor is Girolamo Cardano. He is an Italian polymath whose interests range from being a mathematician, physician, biologist, physicist, chemist, astrologer, astronomer, philosopher, writer, and also a doctor. One of his key figures is the foundation of probability, and the earliest introducer of binomials, coefficients, and the binomial theorem in the Western world. Partially invented to describe several mechanical devices, he is the first mathematician to make systematic use of negative numbers, and also he was the first to describe hypocycloids, the quantity plane curves generated by the trace of fixed point in a small circle that drills within a larger circle, and the generated circles were later named as Cardano or Cardanic circles. And he published his discovery about Delphi's prior work about cubic equation and his book Ars Magna. These three mathematicians are connected to each other. They are competing because of a solution, so let's discuss about their story. Delphi discovered the formula of a cubic equation, but later on, Tartaglia received two problems in a cubic equation from Senwedacoy and announced that he could solve it, so Delphi's student named Antonio Fior challenged him on a 30 days contest. In this competition, Tartaglia won the contest and had produced his own partial solution to the cubic equation. And because Tartaglia is highly competitive, he even included his solution in the form of a poem, in an attempt to make it more difficult for other mathematicians to steal it. But Tartaglia's definitive method was leaked to Cardano and studied his method. Cardano noticed that sometimes it requires to extract the square root of a negative number, so he included a calculation about it in his book Ars Magna and published it himself, even though he promised to Tartaglia that he would not publish it. And Ludovico Ferrari, student of Cardano, saw Tartaglia cubic solution and had realized that he could use a similar method to solve the quartic equations. Tartaglia engaged Cardano in a fight over the publication. Cardano argued that when he happened to see Delphi's unpublished cubic equation solution, which was dated before Tartaglia, he decided that his promise to Tartaglia not publishing his solution could be broken, and he even included Tartaglia's solution in his next publication along with Ferrari quartic solution. And another competition happened between Ferrari and Tartaglia. It was a public debate. Tartaglia accepted the challenge but he decided not to show up. And then Ferrari won the competition, and because of this, Tartaglia lost his prestige and his income.
Quartic formula. A function in the form of f of x is equal to ax raised to 4 plus bx cubed plus cx squared plus dx is equals to e, where a is non-zero, by a polynomial degree for a quartic polynomial. A quartic equation is an equation that equates a quartic polynomial to 0 of the form ax raised to 4 plus bx cubed plus cx squared plus dx plus e is equal to 0, where a is not equal to 0. It is derivative is cubic formula, sometimes called as bioquadratic, but bioquadratic functions refers to a quadratic function of x squared having the form of f of x is equal to ax raised to 4 plus cx squared plus e. The contributor of quartic formula, Ludovicius Ferrer, an Italian mathematician known for solving the quartic equation, and a notable student of Cardano, and also he was credited to the discovery of solution to quartic function, but it could not be published immediately. Symbolic notation means to rewrite some things in words by substituting symbols. Various mathematical symbols and abbreviation were widely used during the 16th century. The transition of symbolic notation took so long, the writing of De Cantos has limited impact on Renaissance mathematics until the appearance of Latin transition with the end of 16th century. The contributor of symbolic notation, Francis Bité, often called as a father of algebra, a French mathematician whose works on new algebra was an important step towards modern algebra due to its initiative use of letters as a parameters in equation. The most influential and decisive contributor of the new symbolic notation, he contributed some important ideas in his work on Introduction to the Art of Analysis. He is also known of his works on a polynomial problem and canon in mathematics in 1571. Decimal expansion. The end of 16th century saw the adoption of decimal fractions numbering system, and also decimal fraction become widespread in Europe for general purposes. The contributor of decimal expansion, Simon Stevin, he was a French mathematician, physicist, and military engineer. His works on Desmet, the art of tens, or decimal arithmetic anticipated the innovative adoption of decimal coinage in US.
Let's proceed now in other mathematicians in 16th century. Let's have first Luca Pacioli. Luca Pacioli is also known as Luca di Borgo. He was an Italian mathematician, collaborator with Leonardo da Vinci, and an early contributor of the field of accounting. We all know that Leonardo da Vinci was great in terms of arts, and one of his greatest contribution was Mona Lisa. Leonardo da Vinci also studied math with the help of his friend Luca Pacioli. Next, Luca Pacioli is the father of accounting and bookkeeping. He published books on arithmetic geometry and bookkeeping that quite popular for mathematical puzzle. He also introduced the plus and minus printed book for the first time, and he also investigated the golden ratio of 1:1.618 in his books The Divine Proportion at year 1509. Actually, Pacioli concluded that golden ratio was a secret message from God. It says that it is the secret knowledge of the beauty in a thing. Then, Lastly, like what I said a while ago, Mona Lisa was created by Leonardo da Vinci, and Pacioli investigated about the golden ratio. And we all know that in the image of Mona Lisa, there is also the image of the golden ratio. Second, Raffaele Bombelli. Raffaele Bombelli is an Italian mathematician and author of the Treatise of Algebra, central figure in understanding the imaginary numbers. As we all know, imaginary number is the square root of -1. He was the first European to write down the way of performing computations with negative numbers. So, he considered as the discoverer of complex number. And what is complex number? Complex number is a number that is formed of a plus b, I, where a and b are real numbers and I is imaginary number, which is the square root of -1. Let's have the third one. Third is Albert Dürer. Albert Dürer is also known as Albert Dürer. So, he is known for creating the magic square. So, what is magic square? Magic square is the square array of numbers consisting of the distinct positive integers arranged such that the sum of any numbers in horizontal, vertical, and diagonal lines are always the same number. So, do you still remember that we did the magic square in our mathematics in modern world? Yes, and it is 3 by 3. And Albert Dürer create is 4 by 4. So, what's the difference between the 3 by 3 and 4 by 4? So, in 3 by 3, the answer must always be the same number, which is the 15. While in 4 by 4, in Albert Dürer, the answer is always 34. So, like, as you can see at the first row in the picture, there is 16, so plus 3, that is 19, plus 2, that is 21, and plus 13 is equal to 34, and so on and so forth. Let's proceed with the fourth one. John Napier. John Napier is best known for his invention of logarithms and the usage of rods as multiplication tables. Napier analogy. So, Napier analogy is used in solving spherical triangles. So, as you can see in the formula, there are three formula of Napier's analogy, and the first one is the tangent of b minus c all over 2 is equal to b minus c all over b plus c multiplied by cotangent of a over 2. And the second and the third formula. The next one is the Napier bones. So, Napier bones is made of ivory. Actually, Napier bones is not just made of ivory. It is also made up of wood, metal, or even cardboard. But in Napier's time, it is really made up of ivory. So, what is that ivory? So, based on my research, that ivory is the horn of the elephant. So, Napier bones is used for mechanically multiplying, dividing, and taking the square roots and the cube root. So, as you can see in the PowerPoint, the picture that is the example of the Napier bones. And lastly, John Napier is found exponential expressions for trigonometric functions and introduced the decimal notation for fractions. Next is Johann Kepler. Johann Kepler gave the first proof of how logarithms work at year 1624. He devised a method of finding the volumes of solid of revolution, and also wrote a study of the properties of lenses in which he presented a new design of telescope known as the astronomical telescope. So, as you can see in the PowerPoint, that is the telescope created by Kepler. And that telescope is also named after him. So, it is called as Kepler telescope. Let's proceed now with Marine Mersenne. Marine Mersenne is the one to publish the laws relating to the vibrating string. He also gave the definition of a cyclodurette, which, as the locus of a point at distance from the center of a circle of a radius A that rolls along a straight line. Marine Mersenne is also remembered because of his Mersenne primes. So, what is Mersenne primes? Mersenne primes is a prime number that is 1 less than to a power of 2. And it is in the form of m sub n is equal to 2 raised to n minus 1. Lastly is about Gerard Desargues. Actually, we already tackled about Gerard Desargues in our modern geometry. But like what is written in the PowerPoint, Gerard Desargues is really the one who invented a new or non-Greek way of doing geometry. And it is called the projective or the modern geometry. Where in our discussion, it's begun with the pencil of lines. So what those pencil of lines? So the pencils of line is the collection of straight line that intersects in only one point. That is the pencil of lines. Then, Gerard Desargues has many theorems in terms of triangles. But the one famous perspective theorems of Desargues is when the two triangles are in perspective, the meets of corresponding sides are collinear. And it's written to his book, and Desargues' book is really short, but like what Mom said, it is very dense. Thank you everyone for listening. We hope that you learned from us. Thank you.